Testing, testing, 1, 2, 3, testing, testing. Hello, everybody. Ha. There's lots of activity in chat today. That's interesting. So, just to address the issue of a Facebook group for the class. Wow, chat is so active. This is amazing. So, one of the things, and I'll get to this in a moment, but one of the things that we've set up for the purposes of this class is a Piazza Forum. It's kind of similar to a forum of a regular variety, except it's really quite interesting. It has a number of things anonymized so that you can ask questions about the course anonymously, and it separates instructors from students so that you know when a answer is endorsed by an instructor that it is a answer that we agree is a good answer for whatever question's been asked. So yes, that's if you're going to direct that type of traffic to somewhere, then please direct it to the Piazza Forum rather than Facebook. And besides, Facebook is evil anyway. I don't know why you'd want to use it. So anyway, welcome to Computer Science 1MD3. We are going to be talking about computers. Specifically, this is an introductory course in Python programming. If you're here, you're probably here because you've heard about this thing called programming. You've probably seen a computer before and you're like, hey, that sounds like a fun thing I want to do sometime. So, we're going to learn stuff. We're going to learn stuff about how to do stuff on computers. This is fun. So, since, could I upload the video to Avenue to Learn? I'm not sure if I can, actually. Could I tune up the bitrate? Unfortunately, I can't tune up the bitrate. Unfortunately am in the position of having to do this on a really crummy old laptop, although it is particularly bad today for whatever reason. Yeah. So, with respect to that, yes. Lots of people saying hi. This is awesome. So, when I'm looking down here, I'm looking at the chat on my phone. I find it's useful to do two things at once. So, yeah, the quality is terrible today. Very strange. Not sure why. I actually, over the break, I had a guy come in and look at the internet and try to fix the router so that this wouldn't be so much of a problem, but apparently, oof. Yes, the stream will be saved. It'll be available on YouTube. I'm not sure if there is much point in putting it up on Avenue to Learn if it is already on YouTube. Yeah, it will be able. You'll be able to replay all of the lectures. If any of you have already looked at the old lectures, you'll be able to see, how things went last term. You may notice I've tried to put a little bit more polish into the stream since then. Frame rate notwithstanding, it is terrible today. Oof. So yeah, streams will be available post-fact. I am streaming from my place of residence. This is the place I live, so I don't know. You might see my cat at some point. Might bring my cat out. Anyway, so let's dive right into it. We'll talk first about what we're looking at for the course this semester in terms of your expectations, like what you can expect, what is expected of you. The number one-stop shop for all of this type of information is, of course, the syllabus. So, my name is Nicholas Moore. I will be your instructor this semester. I am a rather senior PhD student who's probably going to be cracking off the defense in a couple of months or something like that. We'll see how it goes. We have, at the moment, 3 TAs. We're still working on getting a contract for a 4th TA. There's a slot open for it. We had someone lined up, but then they got a better job, so they had to take that because, you know, if you get an offer of a better job, you should take it, generally speaking. But, yes. Imagine not having tails, cat gang. Anyway, that's your first meme for the evening. So, anyway, there are a number of important websites which you will need to sort of have on your radar in order to interact with this course in the manner in which it's intended this semester. If you're watching this, then you've already found the first one, which is the live stream lectures on YouTube. This is my personal YouTube channel. It's not a school channel or anything like that. That doesn't really exist. If you manage to find the syllabus in which you found the YouTube channel link, then you'll already know what Avenue is. However, this third one is one that we're going to have to talk about a little bit. The system that we'll be using to administer all of the assignments and all of the assessments, which we'll get to what the assignments and the assessments look like. When I say assessments, I mean the exam, the tests, and the assignments. All of these are going to be done through a online system called Jupyter Hub. Jupyter Hub is a server that is administered by the IT personnel within the Department of Computing and Software at McMaster University, somewhat remotely at the moment, I would think. And this, well, I'll show you what it looks like. So this is what you will see, well, sort of, when you take a look at, when you first open Jupyter Hub. I'm just going to make a new folder here. Something like that. Come on. We'll just jump in there. Oh, this is stuff from last semester. Ha 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 ha. That's fine for now. So essentially what you'll be doing for the assignments is you'll have this Jupyter Notebook interface. So what you're looking at right now is a File Explorer view of all of the files that are contained on a local instance of the Jupyter system that I have running on my own personal laptop. I have a question. How long do we have for submitting assignments, Dr. Moore? First of all, I'm not a doctor. I'm a mister. I'm not a doctor until I graduate. Generally speaking, this is a 7-week course, and there will be one assignment. Well, there are 6 assignments. There's no assignment for the exam week because you'll be having an exam. Yes, as you guys have been saying in the chat, you absolutely do need to have a VPN connection in order to access Jupyter Hub. So let's put Jupyter Hub on ice right now, and I'll explain the VPN issue. So when you want to access lots of things from McMaster, not just the Jupyter Hub server, if you want to get access to the full library stuff and other sorts of things, what you need to do, you need to establish a virtual private network with the, which is essentially a, well, it's very technical and complicated what a VPN actually is, but what it essentially allows you to do is to spoof yourself into another network under certain credentials. So McMaster has its own VPN software. It's done by Cisco. If you want into McMaster, you absolutely 100% have to use McMaster's own VPN software. This is a very important point. I've already had a couple of people who have gone astray on that. not just any VPN will work. This is not a sponsor for... I have not been sponsored by NordVPN. I have been sponsored by McMaster VPN. And my internet is super, super slow for some reason at the moment. But probably has something to do with the frame rate or the compression. Yeah, so here we are. The Cisco AnyConnect VPN, there are instructions on how to do this for Windows, Mac OS, Linux, etc. Follow the instructions, get the VPN, then you will be able to access JHub 2. That is how that works. If you don't, then you won't be able to access it. That being said, we do have an alternative method of assignment submission this semester. In addition to JupyterHub, we're going to be doing a parallel process with Avenue, but I will get into that a little more as we get into the nitty-gritty of what we actually expect for the assignments. So, VPN, you need that to get to JupyterHub. Once you get to JupyterHub, it looks like this. You've got a bunch of folders, you've got a bunch of these little book icons are notebooks. If you open one up, you will see essentially, and this is kind of cool, you'll see a bunch of text interspersed with coding blocks, essentially, which are in the middle of the text. So if you want to answer a question on an assignment, which presumably you will if you're taking this course, you would take the code block underneath the question and you would, write your solution to the problem that you're trying to solve inside of this block. These are fully executable blocks that run arbitrary Python code, so you don't have to worry about it being like a restricted subset of the Python language. It's everything like this. The code that you write in these blocks will be code that you could write anywhere you use Python. So that's, rough introduction to JupyterHub. So JupyterHub, very important. That being said, all of the JupyterHub notebooks will also be available. Question. To establish a VPN, we would need a stable internet connection. Is it possible to submit assignments using a local version of Jupyter Notebook and then submit via Avenue? That is, Emily, that is precisely what we are... that's the alternate method that I was just about to talk about, actually. So, as Emily correctly points out, in order to establish a VPN network, or a virtual private network, you need reasonably continuous internet access. This may not be available for certain people in certain regions, and so there is an offline method of accomplishing this goal. If you take a look at on Avenue, if you take a look at the assignments under assessments, you will see, and you'll be able to see a lot more than you currently can, but there will be an assignment. Assignment 1 is currently up there. If you download that, then attached to that is a JupyterHub notebook. So to answer your question, what is the suggested IDE when writing code for assignments? You're basically required to use Jupyter. The assignments themselves come as a Jupyter notebook. So if you want to be able to, essentially, for the more technically minded of you, they are, I think, essentially XML file. No, I think they're JSON files. So the formatting is a JSON file, but that gets parsed into a, something readable by Jupyter itself. So there is a way to run a local instance of Jupyter on your own system, kind of the same way that I am doing, so that you can run Jupyter from your own computer and you don't need internet access or anything. this is what this tab in my browser is. When you run it, it's just a tab in one of your browsers. Excuse me. So you would do your assignment in the browser like this. You would save that workbook, and then you would submit the entire workbook to Avenue through the Dropbox folder. It's very important that the answers that you want to give us are returned to us in the form of a Jupyter notebook, because there is a specific reason that we're using Jupyter notebooks here, and that's because there is a high degree of marking automation that's available to us in order to be able to make the marking of the assignments require a lot fewer man hours. This has a couple of positive benefits for you. For one thing, you don't have to wait 2 to 3 weeks to get your assignments back to see how you did. You will be getting feedback on your assignments within a couple of days rather than a couple of weeks, so that's good. And also, it frees up resources so that we can have more people accessible to you personally. For example, with the Piazza Forum, we actually... Oh, this isn't actually... Okay. My goodness. With the Piazza Forum that we have set up, I have actually assigned one of the TAs specifically to the role of being on call to answer questions that you guys might have on the Piazza Forum. So we'll see, we'll see what we can get our forum response times down to this semester, but hopefully we'll be able to answer, most questions that you might have within, a few hours, certainly within a day. But the idea is kind of a quicker feedback than you might get by email. So I have a question. Will this course be very hard for ones who have never learned Python before? Yes. I'm terribly sorry, but there's no two ways about it with this one. This is not an easy course. It's sort of... Yeah, there... Oh, hey! Basil is the one of the TAs. He is in the chat right now. He's the guy who's the Piazza guy, so he's your go-to contact for all things forum related. So, with respect to the difficulty of the course, it is a reasonably intense course. We get into stuff that I would consider reasonably advanced and difficult stuff for an introductory course. Obviously, this is nothing compared to what you might see in a third or fourth year computer science class, but the topics that we're dealing with here are more advanced, I guess, than you might see in a typical programming 101. I have a little bit of experience teaching the sort of college level equivalent of this course at McMohawk, and at Mohawk, they come up to about, I would say, lecture 3 or 4, something like that, of this course, and obviously we're going much further than that. So, recursion is a tough topic. Classes are a tough topic. We'll be doing a little bit of database stuff at the end, which is, it's not really difficult, it's just very different from the rest of the material. It's extremely useful, though, to know a little bit of databasing stuff. So, with respect to the difficulty of the course, yeah, this is a hard course. You're going to, this is an intense course. This is a compressed schedule. We only have so much time in this course to cover the stuff that we want to cover. So we're going to be moving at a quick pace, and the material is not going to be easy. So, that being said, it's also designed to take you up from nothing, right? So this course is designed to start from, I have no programming experience, but I have done high school mathematics, like the advanced functions type stuff. So, A friend of mine opened another question from the class. A friend of mine opened assignments on Jupyter and accidentally submitted already. Should they just resubmit it? Yes. So the thing about Jupyter Hub is that only the latest assignment submission is kept or counted. So when you make multiple submissions through the Jupyter system, the old one is deleted in favor of the new one. So there you go. Why do I only have 3 hours for the VPN? I don't know. You should ask UTS. So how helpful/useful is the textbook? It depends on what you mean by helpful and useful. If by helpful and useful you mean good reading material, then yes, it is excellent. Excellent in that regard. However, there are no questions in the textbook, no practice questions. The topics in the lecture are loosely based on the stuff that's in the textbook, so it's not like the lecture slides have come directly from the textbook. So with respect to the textbook and the weekly readings, it's really like for those people who learn best by reading, or if you want to do a deep dive into a couple of the topics that we are going to talk about, then I would recommend looking at the textbook chapter that is relevant to whatever section we're on. So hopefully that answers your question. I wonder how many of these people are CompSCI students. So my understanding is that there probably won't be a whole lot of CompSCI students in this class. The registration for this class was completely open, and I'm sorry. I've got a patch of grass growing that I'm trying to grow. The city did some work, and I've been trying to grow grass over the dirt that they left. And these pedestrians, a young child and a mother, just went by, and the mother allowed the young child to stomp on my grass for a little while before pulling the child away, which is extremely frustrating because I, in fact, put up a little barricade with string to try to indicate that I'm trying to grow grass there. Ugh! Anyway, that's the dangers of working from home. You get distracted by pedestrians. Anyway, so with respect to Math 1 MP3, I can't really talk too much to that. Given that I have never taught the course, I'm not aware of what the course content is. My understanding is that it's not quite as tough, and this is mostly from me reading damage to it. That's the one thing that small kids have going for them, is that they don't weigh very much. Anyway, so what was I talking about? One MP3. Yeah, so I've had a few people who like, should I take this one? Should I take that one? This one might be a little harder. This one might be a little easier. It really, like, I don't know. It's up to you, really. One MP3 might be a little bit easier. I don't know. I've been told that my course is tough but fair. So, yeah, I don't know. We'll see. I don't know. Maybe you like me. Maybe my winning personality is enough to keep you in my class. I don't know. If you do want to leave, though, I'm sure there are other people who want the slots, because there usually are. Yeah. Well, anyway, so let's keep moving on. Incidentally, a note on the structure of these lectures. I am intending for there to be a 10-minute break between each hour of lecture. 3 hours is a long time to sit and listen to anyone or anything, and I realize this doesn't matter quite so much for the people who will be watching it afterwards, but for us who have to endure it at the time, then it's going to be it's going to be a long night if we have to do 3 solid hours of everything. So we'll have 10 for Anaconda. So if you go, I know it says pricing, and that always gets that always looks scary, but basically, if you download the open source free version of Anaconda, you will get in it the Jupyter installation that I'm currently using for this class. Yeah. As long as the audio is coming through, that's the main thing. Maybe. No. Don't listen to me, YouTube. Anyway, so if you download Anaconda, you will get Jupyter. Jupyter may be used to complete the assignments and the tests and the exam offline. You could then upload stuff to Avenue. So that is a cool way of doing that. Again, Piazza is our anonymized message board / forum. I will occasionally post interesting information there, but anytime I post anything, it'll be to the announcement feed on Avenue and Piazza, probably. Although Avenue is usually the best source. It still wants me to log in. Jeez. Okay. Anyway, I should have signed up everybody in the class that I have so far, but if you just joined the class 30 seconds ago, then there's a link there for you to join it. Lectures will occur Mondays and Wednesdays from 5:30 to 8:30 p.m. Eastern Standard Time, and will be live streamed from the instructor's YouTube channel. Lectures will be available for viewing after the time of streaming. Class participation will occur using YouTube's built-in chat feature, as we can see everybody's using to currently make, call other professors of other courses names. Are there participation marks for tutorial, or can we stream it afterwards? There's no participation. There are no participation marks for anything ever. All of your marks are derivable from your answers on Jupyter stuff. So, will there be a tutorial today as well? No tutorials this week. There will be no tutorials this week. But we'll, next week we'll start them. So, tutorials will occur Mondays and Wednesdays from 8:30 to 9:30 Eastern Standard Time. That is the hour after this. GLI or CLI for Anaconda. GLI, CLI? I'm not sure what that means. Oh. You'll probably want a graphical installer, just because, I mean, if you're using Windows or Mac, you probably like doing things graphically, and if you have a Linux machine, then what are you even doing taking this course? You probably know everything in here already. Ha ha ha. Anyway, so as you can tell, I'm actually I try to be fairly interactive with chats and answers people's questions on the fly. Chads might use CLI, but this isn't necessarily a course for Chads. This is a course to get you to Chad level. Will the tutorials be saved for viewing after the live stream? My understanding is that the ones on YouTube's will. However, the one that is on Zoom, I'm not sure if the Zoom platform supports that. So, if not, then you can always catch either Basil or Swale's tutorials on YouTube if you happen to miss Meddy's. Linux for the win. Anyway, with respect to office hours, I will not be holding office hours because, pandemic, etc. However, if you want to email me, please feel free to email me or the TAs. If it's like I'm not sure what I'm doing wrong on an assignment question type thing, please send that to Piazza, because you can very often find other people having similar problems on there. So, we've got prerequisites for this class: Math 1 KO3, Math 1 1LS3, grade 12 Advanced Functions and Introductory Calc, or grade 12 Calculus and Vectors. Anti-requisite is Engineering 1D04, which is the big first-year programming course that the first-year engineering students do. This is not an engineering program. This is a computer science program. We are much more abstract and hypothetical here. If you get a message that says not enrolled on Piazza, then on the syllabus there is a link to become enrolled. So, trust me, by the end of this course you'll be Chad level, if you survive it. Anyway, so let's talk about what we want to achieve in this course. Number one, we want a basic working knowledge of Python, the programming language, not the snake, and by extension, imperative and object-oriented programming languages. It's kind of cool. The thing about programming languages, and people say that this doesn't, your mileage will vary with this statement, but it's generally true. If you know one programming language, you know a bunch of programming languages, because each style of programming language has 4 or 5 mainstream programming languages that all adhere mainly to the same principles. So the focus in this course, as it is in most university courses, is to teach you the principles of programming rather than dwell overly much on the particular specific details. That's more of a college approach. That being said, we are definitely going to try, I generally take a applications first sort of approach to this course, so hopefully you'll be able to acquire some useful real-world knowledge. So, next, you would want to achieve a level of Python proficiency sufficient for scaffolding further exploration of programming as a skill. Basically, you should learn the Our super chat set up. Wait, stream donations. No, I'm already I don't know. Interesting idea. It's kind of, I don't want the money. I'm already getting paid for this. Also, my channel doesn't have enough subscribers or view time to be monetized anyway. So I think that if I've never seen anything about setting up super chats. I'm pretty sure that if you want to set up something like super chats, you have to be in the category of a monetizable channel, which I think you need 1,000 subscribers, and I'm up to 80 some, I think. So like and subscribe. No, I don't know. If I don't catch your question the first time, just spam it, I guess. That's a terrible advice. Don't spam it, just repeat it once. Hopefully I'll say it that time. So, let's say I have trouble understanding a concept like classes, for example. What would be the best way to get help? Asking any particular specific questions you have, you can take to Piazza. There's also, this is kind of one of those topics that there's a million tutorials on YouTube about. So if you're having particular difficulty with an issue, and this is kind of like my a life recommendation, #life recommendation. If you're having excessive difficulty with something, see if there's a tutorial on YouTube about that specific topic, or something like that. But anyway. So, anyway, back on topic. We're also going to learn how to organize, write, document, and test medium-sized programs. So that we'll be talking about a bit about mid-course. We need an awareness of the limits of computation. That's an interesting one. A lot of people think that computers can just do anything, which is not true at all. Computers are not magic. Computers have very strict rules that they abide by, and if you don't know what those rules are and you expect computers to do things they can't do, then you're setting yourself up for a world of hurt. If we monetize all your streams, we can split the profits. Yes, I will give you the other nickel. How's that? What to do when the criteria isn't met to log into VPN? So the criteria to log into VPN will be your MAC ID. If you don't have a MAC ID, then you should not have been able to enroll in this course. So everybody should have a MAC ID. So the ability to bring informal problem statements into a computational formulation. Basically, you need to be able to solve a word problem, and the ability to apply algorithmic techniques for solving complex problems. That is, like, that statement is basically the entire course summed up in one sentence, right there. So, I'll skip the calendar description. So, let's get to the question. I connected to McMaster's VPN and clicked. Okay, that's a good point. So, there are no files in my notebook list. You have to fetch them. So I don't have it installed on this particular one, but if you if you connect to Jupyter Hub, at the top here, it'll be files, running, clusters. There'll be another tab that's assignments, right? If you click on the assignment tab, you'll have a list of the assignments that are currently available. You have to perform what's called a fetch operation in order to retrieve the assignment to your account inside of the Jupyter server, and then you'll be able to see it, and you'll be able to fill it out, and you'll be able to submit it. Okay. Hopefully that answers your question. It doesn't matter if you do the graphical or the command line installer, but I suggest doing the graphical one because it's easier. Easy is good. Easy is not always just for weaklings. It can just make things easier. So, anyway, let's get to the topic everybody wants to know about. How am I going to be evaluated this semester? So, there are 3 categories. All of these assessments are going to occur through Jupyter Hub. You've got assignments, tests, and the final exam. Assignments are worth 40% of your final grade, tests 30%, and the final exam also 30% of your final grade. All of the evaluations in this course are individual in nature. No group work will be assigned. All assessments in this course will use Jupyter Notebooks, and there are 2 ways to get and complete assignments. Number 1, log into Jupyter Hub directly. Assessments may be completed in browser and submitted using the Jupyter Hub interface. This option requires that you use a VPN connection when off campus, which, let's face it, we probably all are. The alternative, and this is basically good if you have difficulty with the VPN connection, you can download the assessment in the form of a .ipynb Jupyter Notebook from the Avenue assignment folder, and then you can use a local installation of Jupyter to complete the assignment. Then upload the notebook to Avenue in the appropriate assignment folder. If you do not submit a Jupyter Notebook, you will get a 0 for the assessment. So the take-home message there is, don't just make a Python file with all of your answers. In order for the autograder to work, it has to be a notebook, and in order for it to be a notebook, basically it has to be the thing that you downloaded, but with you having filled in the stuff. So don't just give us a Python file. If you just give us a Python file, you'll get 0. I have a few questions. Let me see if I can catch up. Yes, Droovy. So I don't think you'll be able to use a VPN client other than the McMaster authenticated one. So you have to go and get the McMaster VPN. This guy right here. Pretty sure no other VPN will work. If you can get it to work, you're probably a hacker. Is it the same thing if you do Windows? Yes. So the login for Jupyter Hub is your Mac ID. Yes, it is the same for Mosaic or Avenue. Is it the same thing if you... Yeah, so the assignments that you download from Avenue will be exactly the same in terms of content as the ones that are on JupyterHub. Otherwise, that wouldn't there wouldn't be much point. So yeah. Where are we here? There we go. So, please listen to this information because it's super important. Assignments will be written using the online learning platform Jupyter, which we've already talked about. The assignments are designed to reinforce the material presented in lecture as well as the tutorials. Completion of these assignments on an individual basis is essential to your success in the course. There will be 6 weekly assignments for this course. Late submissions will not be accepted. Late submissions will not be accepted. Assignments will be due Sunday at midnight weekly. For further information, please see the timeline outlined in Section 4. Assignments will be auto-graded using JupyterHub. Assignments will often contain bonus questions, which are more difficult in nature. However, the amount your assignment marks will contribute to your grade cannot exceed 40%, even if, for example, your average assignment mark was, for example, 110%. So, not only the assignments, but also the tests and the exam will all have bonus questions. So, there you go. Will Jupyter evaluate differently based on the efficiency of the solution? Generally speaking, no. So, it's kind of touches on a larger issue. The issue around efficiency is that when you're talking about programming, efficiency, like, things can get super efficient, and like making programs more efficient is an academic discipline. People write papers on it. Academic careers are made on making algorithms more efficient. It's too much to expect for a first-year course. So what we do is we evaluate your solutions to questions on the basis of, given these inputs, do they produce the correct output? This is also known as the black box method, which is something we'll get to when we talk about testing. Generally speaking, the writing of efficient algorithms is, that's kind of a discipline unto itself. The other thing is, like, the only way that you're going to learn to program and learn to program well is by trying and doing. And if you don't know stuff and you're trying to do stuff that's outside of your domain of competence, let's say, you're going to make mistakes and you're going to do things inefficiently, right? You become more efficient as you get more practiced, but we don't want to set the initial barrier to entry so high that nobody can become proficient in programming. So yeah, you're allowed to make inefficient programs. You're allowed to you're in fact allowed to get questions wrong. It's not it's not like the course is being evaluated 100%. You must get every question in the entire course right. That would be unreasonable. So, at the moment, I'm gonna start ignoring people who are talking about VPN issues or trying to get into JupyterHub, because I had hoped to be through this document by the time of the first break happened, and we're not going to be able to do that. So this is slowing things down a little bit. I will hopefully, you guys in chat who know what you're talking about, if you could help out the people who are asking for help there, that would be fantastic. So anyway, tests. There will be 2 tests distributed throughout the semester, hopefully relatively evenly. The tests will be in take-home format and distributed through JupyterHub and also Avenue. The tests are open book tests, but collaboration between students on test questions will not be tolerated. You will have 24 hours to complete each test. The tests will not be cumulative, although the concepts in this course are kind of naturally cumulative, especially the first 4 lectures or so. That stuff is everywhere. It's unavoidable. Each test is worth 15% of your final grade. Tests will also feature bonus questions, but the total amount of your test grades is capped at 30%. So we don't get marked down for our solutions not finishing within half a second, or another arbitrary time limit. No, to Alex Chen's question. That being said, I think there's 1 or 2 questions in the unit on recursion where we are testing like a specific simplification mechanism, and unless you use it, you'll get a result that blows up way too much. So there's like 1 question in the middle that does that, but no, there's no watchdog timer or anything. That being said, if any of the questions that you're writing on any of the assessments in this course take more than half a second to execute, you're in an infinite loop. And that means that your program will never terminate. So just stop it and see where you made the mistake, basically. I can do an example of how to submit an assignment in a bit. It's kind of, I can't exactly run the stream that I'm doing here. Like, it's bad enough already. I can't exactly run it through the VPN, and that's the only way I could get at JHub 2 while doing a stream. So we'll make a tutorial document or something like that. So there we go. So the final exam. The final exam will occur at the end of the semester. See the timeline. The exam will be in take-home format and distributed through Jupyter Hub and Avenue. The exam is open book, but collaboration between students on test questions is strictly forbidden. You have 24 hours to complete the exam. The exam will be cumulative, obviously. The exam will also have bonus questions, and the amount of your final the amount your final exam may contribute to your final grade is capped at 30%. Good. So, let's talk about the extension and late submission policy. There are no late submissions. If you're submitting it late, it doesn't exist, basically. So, if you invoke an MSAF for an assignment, the result of that will be an exemption for that assignment, right? So you will not, it's not going to be a delayed due date. It's not an extension, it's an exemption. What that means mathematically is that the weight of that assessment will be distributed evenly across all of the other assessments in that category. So all of the weight of all of the other assignments will be increased. If you invoke an MSAF on a test, that will increase the weight of the other test to 20% and the final exam to 40%. For the final exam, standard university policy will be applied. For example, the policy on deferred examinations. MSAFs must be submitted online at the website address listed, and if you require accommodation beyond the scope of an MSAF-related policy, please email the instructor, me. You will be expected to argue your case, basically. I can't just give you, I can't just let everybody off of every assignment that, But, at the same time, I understand that this is, like, really stupid and difficult circumstance. The world is in a crazy place right now, and crazy things are happening. And, just generally speaking, if you, go out and break your leg tomorrow and need an MSAF and get it, and then, 3 weeks from now you go out and break your other leg, it's not like I'm not going to recognize that as, a legitimate reason for, some relief. But, you'll be expected to have a good reason, but if you're reasonable, we'll be reasonable, basically. So I'll just answer a couple of questions, and then we'll take our first break. Okay? So, may I make a short YouTube video on submitting files? Yeah, that might work. You said 24 hours to complete them. Will the tests usually take longer than 2 to 3 hours? No, they're generally speaking designed to take around 2 hours. But, mileage may vary. It's actually really difficult to set the length of a test. That's like this is the third time I've taught the course, and I think I'm just kind of now getting on to getting reasonably good at setting what the length of a test should be. But anyway, 2 hours is what I'm planning for. Is there a recommended strategy for anyone who is struggling? Seek out help from either the TAs or myself. Generally speaking, the more specific your question, the more specific our answer. The Piazza Forum will also be helpful. And as I said before, you can actually find a reasonable amount of useful information on other internet sources like YouTube videos. Anyway, so thus ends section 1. We shall resume at 6:30. And we're back. So, I have a question about, since there are no practice problems in the textbook, where might I acquire some? If you go on Avenue to content, I have posted a few links there that you might find interesting. If you go to extra resources, you'll find a whole bunch of different links to things once it frigging loads. Yeah, so exam syntax reference sheet is only really relevant when we're having paper exams, which we are not this semester. But, excuse me, I highly recommend CodingBat as a place to start. Excuse me. It's got a number of useful programming problems that start from a really basic level. So there you go. Haha, I'm back. So anyway, continuing on. So let's talk about the course timeline. This is a 7-week course. We have lectures Monday and Wednesday. They are on different topics. Assignment 1 will be due at the end of this week, which means May 10th. Sunday, there we go. Sunday midnight, May 10th. That's when assignment 1 is due. Fortunately, it's not that difficult. Also, it should already be up on Jupyter. So if somebody who has access to Jupyter, if you could check to make sure that you can download assignment 1 and just say so in the chat, that would be fan-flipping-tastic. Thank you very much. Oh, pardon me for a second. I forgot to close the door. I thought the resonance in this room was off. Anyway, aside from that, the important things are the weeks in which the tests are going to occur. So we're having our first test in the 3rd week, our second test in the 5th week, and our exam in the 7th week. The test and exam schedule is given as follows. For test 1, our start time is May 23rd at 9 a.m. Eastern Standard Time, and our end time is Sunday, May 24th at 9 a.m. Eastern Standard Time. For test 2, that is June 6th at 9 a.m. to June 7th at 9 a.m. And for the final, it's June 20th to June 21st, both at 9 a.m. There we go. Okay, assignment 1 has been confirmed. And I'm quite sure it's up on Avenue anyway, So a note on people with testing accommodations. Oh, one other thing. May 18th is Victoria Day, and that's a holiday, so we won't be having any live streams because it is a holiday. Good. Excellent. For individuals with testing accommodations, extra time will be allotted in accordance with your accommodation plan. So if you have an extra 20 minutes for every hour or something to that effect, that's 24 hours, so you would get an extra 8 hours to perform to do the test, essentially. Accommodation testing will be performed in accordance with the relevant McMaster University policies. So, resources. There's a textbook, as I've already mentioned. It is recommended but not compulsory. The textbook is John V. Gutog's Introduction to Computation and Programming Using Python with Applications to Understanding Data, 2nd edition. And that is mostly a textual reference book. Also, if you need to call a function to check that it's right, should we delete the call before submitting? It shouldn't matter. I don't think it matters. To Maria's question, if you call so generally speaking, the assignments will contain specific cells that are dedicated for the purposes of testing your answer. You will be able to check your answer there probably most of the time. However, if you want to run it, you can run it inside of the block that you've defined the function in, or a little later on. As long as the block has been run, then the function has been loaded into the local interpreter. That's the main thing. And if you don't understand what I just said, don't worry, you will by the end of this. So, you can buy the book, whatever. There's another book. I'm not going to worry about it. Getting assistance. So, because of the sheer volume of people in the class, it would be really easy for me, your poor, humble instructor, to become completely swamped. So, when seeking assistance, please try to do the following things in the following order. Number 1, Piazza. We have set up the forum using Piazza, where students may ask questions anonymously and receive answers from our instructional team or their peers. That is, other people in the class. Check to see if someone else has had the problem, and if not, post your problem. It's quite superior to the forum system in Avenue. There's no comparison to the forum system in Avenue, to be honest with you. So please, if you have a question about an assignment question, or I don't know what I'm doing wrong here, or anything like that, Piazza is a great resource. There is a TA specifically assigned to answer questions on Piazza. That's Basil. So the response time should be the best of any of the other assistance mechanisms. Number 2, you can ask a TA in tutorial. Number 3, you can email your TA. And 4th, if all else fails, email your instructor. Myself. So, academic integrity. This is an online course. That does not mean that we are not applying the standards of academic integrity. Okay? Just because it's online doesn't mean that you don't have to, that doesn't mean that you can use other people's work. All right? So you are expected to exhibit honesty and ethical behavior in all aspects of the learning process. Academic credentials. The academic credentials that you earn are rooted in the principles of honesty and academic integrity. Academic dishonesty is to knowingly act or fail to act in a way that could result in unearned academic credit or advantage. This behavior can result in serious consequences. For example, a grade of 0 on an assignment, loss of credit with a notation on the transcript. The notation reads grade of F assigned for academic dishonesty, and or suspension or expulsion from the university. It is your responsibility to understand what constitutes academic dishonesty. For information on the various types of academic dishonesty, please refer to the academic integrity policy located at that link. The following illustrates only 3 forms, it's 5 actually, of academic dishonesty. Plagiarism, for example, submission of work that is not your own as your own. Improper collaboration in group work. Improper collaboration in individual work as well. Copying or using unauthorized aids in tests and examinations. Allowing your work to be copied by another student. This is a useful thing to know. When answers are shared, the person sharing is as much to blame as the person who uses the shared answer. Okay? So the question from chat is Stack Overflow equal to academic dishonesty? That depends. If the thing that's on Stack Overflow is the assignment question, yes. If you're using Stack Overflow as a resource to aid your knowledge in a particular area, i.e., I can't remember anything to do with CSV files from the lecture, how does CSV Writer work again? Then you can look stuff up on, Stack Overflow. Even the Python documentation is a very good resource for that sort of thing. So, just, you are expected to know whether it's cheating or not. Okay? So, And another interesting one is the submitting for academic credit work that has already been submitted for academic credit, i.e. in a previous offering of this course. If you have taken this course before, you're taking this course again, if you offer up the same answers that you produced the last time you ran this course or you took this course, that is also academic dishonesty. And a lot of people don't realize that. So, in this course, we will be using a web-based service called MOS, which stands for Measure of Software Similarity. Measure of Software Similarity, to interrogate the authenticity and ownership of student-submitted work. Everything you submit is going to be run through MOS. MOS is a system developed specifically for detecting plagiarism in programming code, and it is tuned to the specific ways in which code is plagiarized. MOS, for example, sometimes people think they're very clever and take someone else's work and just rename the variables. That will not fool MOS. MOS generates a plagiarism report in which pairs of submissions are given a similarity score, the highest of which are tabulated into the report. Submissions which have a high degree of similarity are then examined manually by plagiarism, by me, and then you're dealt with accordingly. Do not be fooled. Contrary to public opinion, a person's code is as unique to them as an essay would be. The argument, well, there's only one way to solve a problem anyways, will be dealt with by the swift wings and iron zero-giving fist of electronic justice. Thou hast been warned. Then we have a couple of other boilerplate things. Academic accommodation for students with disabilities, requests for relief for academic missed work, academic accommodation for religious, indigenous, or spiritual observances, extreme circumstances, online participation disclaimer. Any of those things, if you're interested in them, please read them on the syllabus. I don't have time to go through them, unfortunately. The link for Coding Bat just loaded at some point during all of that. So, yeah. So this is Coding Bat. This is a good resource for online Python programs that are external to the course. You can click on a category, click on a problem, and then it will bring up. Good Lord, my internet is slow. How frustrating. So it'll give you a problem statement, and then you write code, and then you click go, and it'll tell you which of these cases came out true, which ones came out false, and basically, for this one, I just wanted to run something, so I just returned the Boolean value true, and you can see that hit all of the ones where the expected output is true, but not any of the ones where the expected output was false. So you can see I don't have them all green here. So it's a really useful thing. It's also got a Java section, which for some reason is a lot more extensive. But we're going to be doing Python, so yeah. And at certain points, the tutorials are going to make specific reference to Coding Bat problems as well. Do we have to download Anaconda if Jupyter works? No. Is there a percentage threshold for similarity, like 5%? I'm not going to tell you. So I see. I may have worried some people. So generally speaking, you don't automatically get dinged for plagiarism just because you have had a higher similarity rating to someone on MOS. Generally speaking, what is considered a high rating on MOS is like upwards of 50%. You know, if half of everything you've written is exactly similar to someone else's, then you probably cheated. But generally speaking, I don't move forward with an accusation unless I have some pretty compelling evidence from the submissions that they were improperly collaborated on. Generally speaking, that usually constitutes something like, you know, both people had a really like interesting, bizarre way of solving one particular aspect of a problem. It's sort of like the same mistake scenario. But anyway, don't worry about plagiarism. Just do the course, and everything will be fine. Just don't cheat. Best way to not get dinged for plagiarism is to just not cheat. So anyway, let's move into an actual topic. Our first topic for this, our spring semester on programming. So, let's talk about how you formulate math problems. Great place to start, right? So, what is the square root of 25? That's a math problem. What is the square root of y? That's a different math problem, right? It's much more difficult to find the square root of any arbitrary number than it is to find the square root of some specific value, right? It's the difference between arithmetic and algebra. So, with respect to the square root problem, we might say something like the square root of y is some number x such that x times x is equal to y, right? So, with respect to problems of this nature, when we are programming, we are talking normally about problems of the second type. So, generally speaking, you can think of programming as being a skill that leads directly from algebra rather than directly from arithmetic. So, let's talk about a problem, a specific problem. Let's say that we had a function, f, and we wanted to find the x-intercept of this function. First, of course, you need a definition for an x-intercept, but hopefully nobody needs one at this point. That is the point at which the function crosses the x-intercept, the x-axis. It is x such that f at x is equal to 0. So we have a couple of conditions on this as well. F has to be a monotonically increasing function on the interval a to b. So we want to determine what the x-intercept is with precision epsilon greater than 0. So, step 1, what we're doing on this slide is we're outlining a procedure for finding the x-intercept. I believe it's Newton's method or something similar. So, number 1, as long as b minus a is greater than epsilon, go to step 2. Otherwise, go to steps 2 to 4. So, we calculate a midpoint between a and b, right? It's in the middle. This m. Exactly in the middle. We then examine what the value of the function is at the midpoint. If that value is different to the value at a, then you know that the intersection is somewhere between a and m. Conversely, if m is on a different side of the axis than b, you know that the intersection is somewhere between M and B. So, using this information, we can narrow the interval on which we know that the intersection is occurring. You know, I set this this streaming up with a slightly narrower field of view, and I might want to expand it a little bit because I kind of like using my hands, and I don't have enough room to use my hands. Anyway, so we then continue to narrow this interval down until we have a very, very tight interval around the x-intercept. Once that interval is smaller than epsilon, we have found the intersection within epsilon, which is the object of this algorithm. All right. Epsilon stands for error. So generally speaking, in engineering applications, particularly or statistical applications, when you're seeing epsilon, which is Greek letter E, you're talking about an error. So, good. So let's talk about the different types of descriptions that can occur. We have declarative descriptions, and we have imperative descriptions. A declarative description tells you what something is, right? They describe what something, like they describe the properties of something. However, in an imperative description, you are describing how to do something. So this corresponds to two categories of programming language. There are imperative languages and there are declarative languages, broadly speaking. So Python, the language that we're going to be learning, is an imperative language. In order to calculate something in Python, you have to say how it is something is done, not what it is something is. It's kind of a clumsy way of saying it. An example of a declarative language would be something like Haskell. I don't know. Do I have any Haskell users in chat? Where's Haskell gang at? Imagine having side effects. Haskell gang. Anyway, I'm actually a reasonably experienced Haskell programmer myself. It's actually, I think, a beautiful language. Programming in Haskell is like programming in the beautiful music of the universe itself. But I'm teaching Python right now. So, so going back to the previous slide, what we have here is a difference between a declarative and an imperative view of the world. So an x-intersection of the function f is x such that f of x is equal to 0. That's a declaration of what the intersect is. This is, on the other side, is a procedure for arriving at it. So this is the what, and this is the how. Yeah, there we go, Haskell gang. Hey, yes. So if you were wondering who the COMPSCI kids were, there they are. Yeah. Actually, it's interesting. The COMPSCI people learn Haskell. They have a course on Haskell in first semester, and then this course in second semester. So, but anyway, so the trick is with imperative descriptions, you're setting out a number of steps that the computer has to follow in order to achieve some result. However, and this is not going to be the first time that I say this in this class, computers are incredibly stupid. So, the instructions that you give them have to be simple. It depends on the language, but generally speaking, all languages eventually have to be compiled down to extremely simple instructions that a computer can follow. Computers only speak math. They really only speak register transactions, but, we won't get into it. Anyway, this leads us into the idea of an algorithm. So an algorithm is a sequence of instructions that can be executed by a machine that, when provided with an input, will eventually stop and produce some output. So, have any of you heard of the expression "garbage in, garbage out"? It was popular back in the day. It essentially is a statement of a property of computer programs that yeah, it's a property of computer programs that it doesn't matter what the program is. If junk goes in, junk is going to come out. But hopefully the program isn't junk too. So, yeah, in terms of an analogy, you can draw an analogy with long division, right? So long division is a process by which you achieve the division of two numbers, right? Using more basic elements of arithmetic. The actual rules of long division, that is the algorithm. The input are the two numbers, the number being divided and the number being from, and the number being that you're dividing by, right? And the output is the result of the division plus the remainder if you're doing it that way. So, an algorithm can be a number of other things as well. Recipes, cookbook recipes, like recipes for making food. These are algorithms because they specify a list of inputs, that is to say ingredients, a list of instructions, preheat your oven to 11 billion and throw 3 cloves of garlic with their skin still on in there, and the output is some degree of food. Edible or inedible depends on how closely or well you follow the instructions. And that's sort of, the analogy is a good one. What do the top people who cook always say? If you start with good ingredients, you'll get good food, right? However, it's not as strict. Lights follow an algorithm as well for the switching of the light. So the inputs are time or car presence in the case when they have sensors. The instructions are the conditions on which lights should be on. Normally this has to do with an internal clock, right? And the outputs are electrical signals to light bulbs, or probably more accurately, electrical signals to contactors, which allow the flow of electricity through other electrical lines. It's very, very rare that you see a circuit board that has a sufficient output voltage to be able to run anything like a street lamp. So, the term algorithm is interesting because it's actually named after a guy whose name I can never pronounce, but I think it's something like Al-Khwarizmi, something like that. Anyway, he, in the 9th century, published a treatise on the calculation of values. The Latin translation was Algorithmi de Numero Indorum, or Algorithmi on the Numbers of the Indians. So the term algorithm is a bastardization of, and I'm using that term technically, of the name of a 9th century Persian mathematician. The same is true of the term algebra, actually. Are these British roads? Why, is it on the wrong side? Yeah. These, I think this is, yeah, that looks like British roads. Very interesting. Very fun. Ha! So, couple of important pieces of nomenclature on this slide. State and trace. So, when you have a program, it is often useful to have pieces of computer memory that are dedicated to that program. These pieces of memory hold intermediate values. So you can imagine it might be useful to be able to say, I have this input, but I have to calculate these things from it, and then I have to calculate more things, and then I can get the result. The internal memory of a program is called its state. The input, to some degree, could be considered an initial state. It is possible to think of an algorithm as state transformation. So you start with some state, you apply an instruction to it, it changes the state. You apply another instruction, it changes the state. You apply instructions and change the state until you have achieved the desired properties in the output. A trace is where you take these intermediate states and you get the computer to tell you what they are, right? So in Python, generally speaking, we use what's called the print statement for that. This is a function that allows us to print the values of variables or literals or any number of things to whatever our output is for this program that we're running. So tracing is the process of getting the computer to show its internal states during algorithm execution, or during computation. Hopefully that's reasonably straightforward. If anybody has any questions about any of this material, please feel free to ask it in the chat. We're only a few slides into it, so maybe everything's reasonable so far. So, algorithms are supposed to be executed mechanically. So, when you give instructions to the computer, they need to be able to execute without the need for human intervention, mostly. So, generally speaking, when you write an algorithm, the less it has to interact with a human being, the quicker it's going to run, because human beings are extremely slow. But mathematics can be executed mechanically because that's the entire history of computational engines, all the way back to Charles Babbage. And mathematics is a mechanizable language, so that's why programming languages are written in mathematics, essentially. So, algorithms have to be precise. Each instruction and the next instruction have to be unambiguous. So, it is there's a difference between the language that I'm using to explain this to you and math, like the universal language of math. When I say something, it is human language is so complex that the things you're saying are often dependent on the context of the other things that you've said immediately adjacent to the thing you're trying to determine the meaning of. This is the power of context. So if you take something somebody says out of context, you will often create ambiguity. And the problem with human language is that there's often a lot of ambiguity going on anyway, because everybody is sort of implicitly operating inside their own brain, which is its own frame of reference. It's its own context, right? If you were aware of every memory that a person had, you would be able to understand everything that they said perfectly, and there would be nothing ambiguous in their speech, hypothetically speaking. But, that's a pretty big hypothetical. Math, on the other hand, it's clean, it's precise, and it always means the same thing. The other thing that an algorithm must be to be a good algorithm is it must be effective. That is to say, each instruction must be executable by the underlying machine. So, again, this comes back to the idea that computers have their limitations. So the way that a computer works is you have memory, things like your RAM and your hard disk and things like that, and you have your CPU. The CPU executes instructions on memory. That's all it does. That is a computer, a thing that executes instructions on memory plus that memory. So, when you take a computer program, we have a process called compilation that takes a language that's written in something that a human can understand, breaks it down into something that a computer can understand. This is, generally speaking, pardon me, that's what an executable file is, right? So a .exe file is something that's written in the binary code understandable by a computer, right? So when you get into the binary code of the CPU, when you get into the instructions that a CPU can execute, there are a finite number of instructions. So every instruction that we use in Python must necessarily be some composition of the base instructions of the computer architecture that you're using, of the CPU that you're using. Yes, good soldiers follow orders. So, let's apply this knowledge to our earlier example of the x-intersect. So, we have our inputs, some interval from a to b, we have a function monotonically increasing, and we have some desired precision epsilon. Our instructions, I won't repeat them, they were on the previous slide. Our output are two values a and b, such that f at a is less than 0 and f at b is greater than 0, and b minus a is less than or equal to epsilon. So, here's a question for you, and you guys can vote in the chat. What happens if f at m is equal to 0 after instruction 2? That is, we are in the case where b minus a is greater than epsilon, so we want to execute a step. We calculate m, right? We calculate the midpoint, and if we find that the midpoint is 0, the value of the function at the midpoint is 0, what happens? Is it A? The algorithm is not precise because it is ambiguous. B, the algorithm is precise, therefore it's unambiguous, but the inputs which would lead to f at m equaling 0 are not allowed. Or C, either instruction 3 or 4 is executed, it doesn't matter. So, vote in chat now. What do you think? A, B, or C? So, we have a preponderance of people, I think, who are saying A. Yeah, sure. D, sure. Well, actually, as things go on, the earlier answerers seemed to be a lot of A's with a few B's and C's, and then as we go on, it seems to be a spike of C's in the middle, and etc., etc. So, let me start by saying it is certainly not C. It does matter whether 3 or 4 is executed. If you have a program which might execute one instruction or might execute the other one, then the output is going to be inconsistent with the it's going to be is there a D? There is no D. You guys are meh. Anyway, if you have a program that doesn't reproduce the same output each time for the same input, that is an undesirable state of existence. So it does very much matter whether 3 or 4 is executed. So the question basically is this algorithm precise or imprecise? Is it ambiguous or unambiguous? So the source of the ambiguity, so epsilon is the error, right? So when you're trying to find the x-intercept, you're not actually trying to find the exact number of the x-intercept. You're trying to find an interval over. You're trying to find what it should be with like plus or minus 3, right? Plus or minus 0.05 or something like that. The plus or if you say it's 7 plus or minus 2, 2 is the epsilon. If that's a way of explaining it. So we have people who think it's ambiguous and people who think it's unambiguous. The people who think it's ambiguous probably think that because we have if f at m is less than or equal to 0, set a to m, and we have if f at m is greater than or equal to 0, set b to m. So the problem with that is both of those include the case where f at m is equal to 0. So if f at m is equal to 0, does it go a or does it go b, right? So the answer to this question is this is a sequence of instructions. It's implicit in the structure of this list, right? That the check for f at m being greater than or equal to 0 is done first. Notice the word otherwise, right? Therefore, this algorithm is not ambiguous. It is unambiguous. So the people who are right are the people who selected B. There you go. Yeah, it's similar to the idea of a margin of error. It's a little more general, but it's highly related to the idea of a margin of error. So, is the output of the algorithm always unique? That is to say, when you put in the same inputs, do you always get the same outputs? What do you think? Okay, the consensus seems to be A, and I will agree with that. The output of this algorithm is always unique because it is an unambiguous. It is not an ambiguous algorithm, even though it might look that way. So, moving right along. Fundamental questions about algorithms. These are methods of evaluating algorithms. So, we have two concepts here, correctness and efficiency. So, when we say that an algorithm is correct, what we mean is that the output that is produced for each input is what was intended. Now, what you mean by intended is a subject that we'll talk about later on when we talk about software testing. But generally speaking, if an algorithm is correct, then the output will be what we expected from the input. So, in terms of efficiency, there are actually a reasonably large number of ways to measure the efficiency of an algorithm. You can have the efficiency measured in terms of time. How long does it take the algorithm to execute? In terms of number of instructions, how long is the program? Normally that has some relation to the time it takes to execute, but not always. What is it in the worst case scenario? What is it on average? What is it in the best case scenario? The other thing that we usually use to measure the efficiency of an algorithm is how many system resources we need. How much memory does it take? How many simultaneous threads do we need to run? If you're talking about something like a supercomputer. So, generally speaking, in terms of efficiency, there are two big categories: time and memory. There are a lot of other ones too, but time and memory are the programming 101 ones that you have to worry about. So, going back to our x-intersect question. Here's a thought experiment. Can we take the exact x-intersect of this function, using this method that we've been talking about? Can we find the exact x-intersect by taking epsilon equal to 0? You may answer in chat. To answer a previous question, if f at m is equal to 0, that does mean that m is the x-intercept. Right. I have a preponderance of people saying B. It seems. This is true. So, the reason that just setting epsilon equal to 0 doesn't work will be familiar to anybody who is familiar with Zeno's paradox. So, if you like ancient Greek guys, which I happen to on occasion, like stories about them, Zeno was a ancient Greek guy who took it upon himself to disprove the existence of motion. So, he established a condition. Let's say that I'm standing in front of a judge, and I throw my spear at the judge. Now, let's say that the spear halves the distance between itself and the judge every second. Then it will never quite reach the judge, because there will always be some remaining distance between the spear and the judge. The same thing happens with this particular example. If the epsilon is equal to 0, then the interval basically we are continuously subdividing an interval and making it smaller and smaller and smaller and smaller and smaller, but it will never reach 0 by division. So from a conceptual standpoint, it's impossible for this to be achieved. From a technical computing standpoint, only the arc side of the Force will allow such power. Yes, happy May the 4th be with you, etc., etc. And please try to hold your opinions about the new Star Wars movies, which I know is just going to cause a cavalcade in chat about it. But anyway, so, what was I talking about? Yes. So with respect to this one, from a technical computing standpoint, you would never be able to reach that anyways, because there is, in fact, a smallest number that can be represented in a computer using floating point notation. However, we're going to revisit this in like 4 weeks, 3 weeks, something like that, when we talk about data formats and why this is impossible in a computer anyway. So, anyway, that'll do it for our second segment today. See you all at 7:30. And we're back. My goodness. Boop. 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 Where's my phone for chat? Oh, for God's sake. So, anyway, getting back into it. I wouldn't know, Droovy. I wouldn't know. Or Doovy. There's no R in your name. Anyway, so flowcharts. Let's talk flowcharts. Algorithms can be formulated textually or as flowcharts. Flowcharts connect instructions and conditions. So, here are our basic things. We've got a rectangle. Those are instructions. Excuse me. The instructions are things like turn green light on, continue straight ahead, subtract V from U. And then we have conditions. Conditions, or rhombuses, are tests. Tests on the state of the program. So, is the drum full? Is the water boiling? Is U not equal to V? Yes, go one way. No, go the other. So, we can compose flowcharts in the manner that you're used to with flowcharts. You can have sequences of instructions by having arrows between them, and in this we will have sometimes circles to indicate the start and end of flowcharts. Stop distracting me with Final Fantasy. Good lord, everybody knows Dragon Quest is where it's at. Oh, mic drop. So, we have, this is kind of important because these are kind of the three basic larger instructions that you will be using so often throughout this course, it will be kind of ridiculous. You got if statements, and you've got loops. So, in the case of an if statement, a regular if statement, we have a condition. If B, then S. In terms of a flowchart, that means, as we see here, if B, the condition B, executes or evaluates to yes or true, then we execute S and then continue. Otherwise, we just skip that statement. We also have if then else statements. So we evaluate B. If it is true, we execute S. If it is not, we execute T. S and T being statements. And then we have the loop. Loops are kind of tricky for your first-time programmer type. So you come into the condition. If the condition is true, you execute statement S, or a group of statements. Then, control of the program flows back up to before the condition, and the condition is reevaluated. If the condition is still true, then it continues to do that until the condition is evaluated to be false, and then control of the program flows past this loop segment. Hopefully that's, reasonably straightforward. So, the most basic way to track data in a computer or in a computer program is the variable. Variables are named locations in memory where data is stored. Unlike variables in algebra, variables in computer programs always have a concrete value. So if you declare some variable x inside of a computer program, there is always some real value associated with x. X is always 2 or 7 or 3272, etc., etc. All program instructions read to or write from some type of memory, be that CPU registers, random access memory, read-only memory, etc., etc. So, we now have assignment instructions. Assignment is the most basic instruction that a computer can have. It is the assignment of a variable. It is the putting of something in the box that is a variable. So, in this particular example, we are assigning e to x. That's the way you say it. E to x, or x becomes e. In mathematical notation, that is colon equals e colon or x colon equals e. In Python, we just use an equal sign, where e is e here is any syntactically correct expression. So, for example, in mathematics, x becomes 7 plus y divided by 2 squared. In Python, the equivalent syntax would be x equals x plus y divided by 2 squared, where you see a couple of the operators have changed. I'm going to try to say x becomes instead of x equals, but it's really, really hard, just so you know. I'll try, but I don't guarantee anything. So, here's an example flowchart for the median of 3 numbers. This algorithm calculates the median of 3 numbers. So, we have 3 numbers, x, y, and z. The median is the middle number, so the number that is in the middle of those 3. So the first thing we do is we evaluate which is greater, x or y. If x is less than y, we go down this branch. We evaluate, is z less than x? If yes, then we go here, x is the midpoint. Otherwise, we evaluate whether z is less than y or not. If it is, then the midpoint is z. Otherwise, it's y. You can see. And this type of branching structure is how you get stuff done in programming. This is an example of a program expressed in flowchart form. Obviously, we have a symmetric structure on the other side for the case where x is not less than y. Again, if anybody has any questions, please feel free to ask them in the chat. So, it is also possible to annotate a flowchart, that is to say, to keep track of which conditions hold at which particular points in a flowchart. These are declarative descriptions. They can help us understand the algorithm and argue about their correctness. However, there is a danger of over-annotating. You can definitely take this too far. You will not be required to do any of this in an assignment, this annotation business, just so you know. So, what is the maximum number of Here's a question, which you may answer in the chat. What is the maximum number of operations required to compute the median of 3 numbers? Keep in mind that the evaluation of a condition counts as an operation. Assignment also counts as an operation. Yep, that's 4. If you take a look, the maximum number of operations that you can have occurs on this branch, this branch, or that branch, and that's 4. So here's a related question. What's the minimum number? 1, 2, 3. It would be 3. That's the minimum number. So let's talk about a different example now. This is a flowchart example for calculating the maximum and minimum temperature from a set of temperatures. So for inputs, we have a set of integers, ti, for 0 is less than or equal to I is less than n, which is a series of n temperature readings, and we have an integer n, which is greater than 0. So the outputs that we want are the minimum temperature and the maximum temperature. So the way that this works, we have I, max, and min, which are assigned 1, T0, and T0, respectively. We then enter a loop. The loop condition is I is less than n, n in this case being some number that's been assigned. If Ti is less than the minimum, then the minimum becomes Ti. Otherwise, if Ti is greater than the maximum, then the maximum becomes Ti. In any case, I is incremented, or I becomes I plus 1. We then return back to the top of the loop. I is less than n. This basically the difference between I and n will be decreasing all the time, and eventually I will be equal to n. At that point, you stop the loop and exit this way. So, for example, if we had the 3 t values, 3, 7, and 4, the number of t values is 3, obviously. Our maximum and our minimum are initially set to 3. Then, for the loop where I is equal to 1, Ti is not less than the minimum. It's 3. Ti is greater than the maximum. Let's not forget that Ti is in this case 7. So Ti is greater than 3, so yes, the maximum becomes 7. For the loop where I is equal to 2, which is the next one, Ti is not less than the minimum. The minimum, of course, is 3, and T2 is 4, and Ti is not greater than the maximum because the maximum is 7 now. We then continue, loop back around, and I is no longer less than n. It's equal to n because I is 3 and n is 3. Therefore, the loop exits, and we have found our maximum and minimum, 3 and 7 respectively. So, question. What is the minimum number of comparisons with Ti when n is equal to 3? So, basically, with these two highlighted comparisons, what is the minimum number of highlighted comparisons that you can run through in the previous scenario? Assuming that the temperatures are arranged optimally, shall we say? Answer in the chat now. Is it A, 0, B, 1, C, 2, D, 3, or E, 4? So we have a couple of people who answered 4. Anybody else have any ideas? A 2 and a 3. So, here we go. I is equal to 1. We pass through here. We pass through here. Ti is less than min. In order to have the minimum number of these, it would have to go this way. So, 1. I is now 2. 2. I is now 3. I is now equal to n. Therefore, it exits. So, the number of times we pass through this one is twice. So anybody who answered C, 2, you have done correctly. Incidentally, the maximum number of comparisons is, of course, 4, because rather than going this way, you would be going that way, hitting both of these on each loop iteration. There are 2 loop iterations, so that is 4 in total. So, these are what we might call best and worst case scenarios. So in the best case scenario, we're talking about a list of temperatures that are strictly decreasing. So every single one is less. Every single one is the new minimum, right? It would be going down this yes branch each time. In the worst case scenario, that you would have the minimum being the first thing that was put down, right? So in fact, this scenario that we talked about here, this is a worst case scenario runtime because the minimum is at T0. All this business about Pogs and PogChamp must be a meme I don't get. You know, I was actually alive when Pogs were a thing. My mom never let me bring them to school because it was basically gambling. Like, do you guys know how the Pogs game actually worked? You had like a stack of these cardboard discs, right? And a heavy metal one, and you would stack all of them, and you would throw down the slammer, and this would scatter the entire pile of them, and any of them that turned face up were given to one person, and all of them that were face down were given to the other person. And so it was like this, you know, you would exchange them with people. Anyway, doesn't really matter. Slightly off topic. Anyway, so programs. Programs are algorithms that can be executed automatically by a computer. You might have been already able to figure that one out. Fixed program computers serve only one purpose. So, for example, some of the early computers, like the one that broke the Enigma machine, and I forget what the name was, and excuse me, things like your digital timer for cooking. Albert, that is a correct assessment. Pogs are cardboard, not fire. Pogs will burn in fire because they're cardboard. My God. Good Lord. Anyway, we have since moved to a more advanced style of computation called the stored program computer. In a stored program computer, the program itself is, as you might expect, stored in the thing that's executing the instructions. So one of the first of these was made in 1949, the Manchester Mark I. The program inside of a stored computer can be changed. sometimes by that computer by other programs within that computer, or even the same program. So we achieved universality by storing instructions in the same way as we store data. This allowed programs to be changed. The universality of machines was anticipated by Alan Turing in 1936. If you know anything about the history of computation as a science, you will know that Alan Turing is the granddaddy of modern computational science. He invented what's called the Turing machine. Wasn't it ENIAC? I don't know. Sorry. So, Alan Turing led a very interesting life. He was instrumental in the defeat of the Nazi war machine via disinformation campaign during the Second World War, because the Allies managed to crack the secret code that they were using to communicate everything with. They cracked the Enigma machine. They did so through computation, which was an incredible achievement, and one of the reasons that we now enjoy, enjoy a life free from the authoritarian dictates of fascist states, and also the reason that the whole world didn't have to learn German. However, he was also tried and convicted of homosexuality in the 50s, I think, and forced to undergo a series of hormone treatments, which the science at the time supposed could correct homosexuality, and as a result, he committed suicide way earlier than he might have. He might have lived a lot longer, except he committed suicide because, his body was all messed up from all of these things that he had to take by court order. Who knows what amazing things he could have accomplished with the rest of his life. Although, that being said, most scientists produce most of their interesting work by the age of 30. But you know that meme where it's like, the world now, the world as it could have been, the world as it could have been if Alan Turing hadn't been convicted of homosexuality. It's like the futurescape thing. Anyway, yes. Yeah, it was, generally speaking, I guess the lesson there is that if you are anything other than a heterosexual, don't go time traveling, unless it's into the future. Anyway, so we've got this thing called the von Neumann computer architecture. This is the essential modeling paradigm. This is the paradigm model for computer programs as they exist. So we've got inputs and we've got outputs. Notice those are separate. Obviously, in our modern context, input devices are things like keyboards and mouses, mice, I guess, and things like monitors and printers are output devices. We have inside of our computer the central processing unit and the memory unit. The memory unit obviously stores stuff, the memory, if you will, and the central processing unit contains the control unit and the arithmetic logic unit. The arithmetic logic unit is the thing that does all of the math-type computations. We won't really get into this. This is more like computer architecture type. Like, you can do classes on computer architecture. This is kind of getting into like electrical / computer engineering type territory, but it's useful to know that this is what's going on under the hood. So, CPUs all operate on bits. So everything is binary when you're talking about a computer. So, generally speaking, we group bits into larger structures because it's very inconvenient to talk about bits. We usually at least talk about bytes. Each byte is 8 bits, although more typically we group things into words, which are groups of 32 or 64 bits, 4 or 8 bytes respectively. CPUs contain their own very limited memory called registers, and they have only a few operations, really. They can load data from memory into a register, do an arithmetic operation on some data in registers, store data from a register to memory, or jump to another instruction based on the value of data in a register. It's kind of incredible, but like 99% of everything that a computer does is some combination of those 4 types of instructions done really, really fast. So that, like, the thing about computers is that they're dumb and they do simple things, but they do them incredibly quickly, and that gives them the illusion of intelligence. Does the bit in Bitcoin mean the same thing? Bytecoins? No. I think the thing about Bitcoin, the reason it's called Bitcoin is just that it's a digital currency. It doesn't, like, a Bitcoin is not 1 bit, right? Bitcoin is like some long serial number, right? That number is expressed probably in terms of bytes or words or larger organizations of bits. But like, fundamentally everything in a computer is bits, so sure, why isn't it? That's probably why they called it Bitcoin. Anyway, so here's a slide on the history of programming languages for you. Fortran was an early high-level language. It stood for Formula Translator, and its purpose was the expression of mathematical formulas into a machine language. The first Fortran programs were written on punch cards. You can see an example of a punch card here. So this is the time that I take to express to you how grateful you should be that you're living in the year 2020, despite what 2020 has been so far, and not the year 1950. Because if you were taking a computer programming course in 1950, you would be given what would look like a stack of library cards, or library index cards. Although you privileged millennials don't even probably know what library index cards look like. Anyway, you would be given a stack of cards, and you would take a hole puncher, and you would punch out instructions into these cards, right? You'd punch out an instruction. That was a card. You'd flip it over. You'd take the next card, you'd punch out the instruction, take it over, put it over there. Make sure you number your cards, because if they ever get out of order, it's almost impossible to read them, right? And then you have to collect up your stack of carefully punched punch cards, take it over to the computer, right? Put it in a slot in the computer, and the computer would automatically flip through all of your punch cards, read the holes in them, essentially, by means of like little things that would like fall into the holes and cause an electrical contact, and then that would transmit what the instruction was to the computer, and then it would like output something like on dots on ticker tape or something, and then you'd have to recompile the answer from binary code yourself, expressed in almost like a Morse code. Almost it. Well, not kind. Well, it would be like up for 1 and down for 0 or something like that. And then you'd have to recompile it back into numbers, and then you would get the answer to your calculation. Is Phase Rush Graves better than Fleet? I think Fleet because of full health, but clears can be 50-50. Nimbus is a must. I don't know what that refers to. I'm assuming a video game. Oh, maybe that's StarCraft? Are we talking StarCraft here? Well, the message has been retracted anyway. Anyway, so that's how things used to be. Later on, we get the development of languages. Started with a thing called ALGOL, then Pascal. Programming languages that get closer and closer to the notation that exists inside of human language. In fact, there's a really old language called COBOL, which was basically made for business majors, and it is extremely verbose and uses a lot of like normal people words to try to make it more accessible to mathematicians. And I hope nothing still runs in COBOL, but it probably does. I think some banks still use COBOL for some things. League of Legends. Okay. I have never played League of Legends. I'm sorry. I'm more of a Civilization guy when it comes to like strategy games. You know, I'm more of a 4X guy than a MOBA guy, if that makes sense. It's quite good. Anyway, that's how programming languages developed. Eventually, it got to the point where the language, like the program, could be stored in memory, which meant we could type it out on the computer itself, which was a huge advance at one point, if you can imagine it. Yeah. No, Civ 4 is the best one. I will die on that hill. Anyway, so compilers. The purpose of a compiler, I already touched on this, is to take a program written in something like Python, or C, or C++, or C#, or Java, or JavaScript, or or Visual Basic, or Haskell, or Pascal, or Prolog, or any number of them, takes those and compiles it down to machine language. So in a high-level language, you might have an assignment statement. U is equal to U minus V. In terms of machine language, that breaks down into load register 1 with U, move U to register 1, move V to register 2, subtract register 2 from register 1, put the result in register 1, or language instructions to do within the realm of feasibility. So, when we're talking about programming languages, and we're talking about a lot of programming languages now, not just, we're talking about programming languages as a thing. There are a number of ways that we talk about them to distinguish them from one another. It is I'll go over that bit again. So when it's doing it means that we distinguish them. A couple of properties that we I'm gonna try to power through the issues we're having with the connectivity. Man, this is stupid. I fixed my internet specifically so this wouldn't happen. I'm so mad right now. So anyway, so we have high and low level languages. When we're talking about a high level language, we're talking about an abstract language. It's kind of the reverse of intuition, but when you hear a programmer say something that's low level, that means more difficult, and high level means less difficult, generally speaking, because high level stuff is more abstract. You can formulate things more abstractly, which means you can write things more easily. Whereas, if you're writing things on a lower level, you have much more direct access to memory and hardware, but it also requires a lot more effort to program that way. Because you have to, for one thing, just write a lot more code, and for another thing, the code that you're writing is a lot less, like, you have to get much more into the headspace of electronics, if that makes sense. So, with high-level languages, we're talking about things like Python, R, and Haskell. With low-level languages, we're talking about things like C, and below that is assembly language. And believe it or not, they're actually even, yeah, possibly. I don't know, my wife could also be streaming something in the other room or something, I don't know. Anyway, there's actually something that's even lower level than assembly code, and that's hardware description languages. That's actually related to the area of research that is my thesis. But a hardware description language actually, you're actually programming circuits themselves, which is very cool, but not at all the subject of this class. There are also a lot of languages that are in the middle of these, Visual Basic and Java, for example. Of the high-level languages, it is this sessional instructor's opinion that of the three listed, Haskell is the highest of the high-level languages. It is also possible to have, at least of the ones listed here, it is also possible to have too high a level language. Once you start getting into things like metaprogramming, you're not even talking about how to write a program anymore. You're more defining things as you're defining languages. Question: does HTML count as a language? No, it is not a language. It is a markup. I know the L stands for language, but no, it's not a language. It's not a programming language. It is a way of annotating a text file in order to make it interpretable to a web browser. It's not a programming language unless you've got if statements and loops. That being said, I'm sure someone's going to find some example of how you can do if statements and loops inside of HTML, and fine, be that way. But generally speaking, people who are programmers do not consider HTML to be programming. So, there you go. So we also have a difference between general-purpose languages and application-specific languages. Application-specific languages are sometimes also called DSLs, or domain-specific languages. SQL is a database language. We'll be dealing with it to a certain extent later on in the course. HTML, which is used for web pages, again, hello. It is not. Most programmers do not consider it to be programming to do something in HTML, but I mean, you can get there. Yeah, it's like people who use LaTeX wouldn't consider using LaTeX to be programming, but it kind of looks a lot more like programming than using Word, if that makes sense. Anyway, you also have R, which is used mainly for statistics and statistical processing. And then you have general purpose languages, things like Python, C, and Haskell. These can be used for anything. Some of them, particularly Haskell and Python, have libraries for just about everything. So you can use them to do just about anything. It's very cool. However, you pay for that generality with, generally speaking, if you're trying to do something inside of a specific application, it'd be quicker and easier to use a language that's designed for that application, right? So, like, if you're trying to work with databases, you should probably consider using SQL rather than Python or C. That being said, we're going to be doing later on in the course how to do SQL queries through Python, so, we'll see. There's also a certain amount of value of having an integrated framework in which you can do a bunch of different stuff. So, we also talk about the difference. Where does MATLAB go? MATLAB, I would put it in the middle. MATLAB syntax is actually based on Fortran, if that's interesting. Minecraft command block is a programming language, and you can't change my mind. What libraries will we use? This is a lot of questions. Okay, what libraries will we use in the course? Those we will bring those up as we use them. I will be sure to point them out, but it'll be stuff, in particular, stuff like the when we start dealing with file formats, there are a number of different libraries that provide stuff for that. Libraries, they give you extra functions, extra functionality that isn't necessarily included in the sort of base version of the programming language you're using. So, for example, if you want extended math functions or random math functions, to save memory, not everything is going to be loaded when you load a program. So you have to explicitly load, or in some cases even install, certain libraries. However, if you're using the Anaconda installation that I pointed to earlier, you'll have all of the libraries you need. My goodness, this is a lot of questions. Is it possible to run multiple languages in a single program? Yes. Yes, it is. However, generally speaking, what you would be doing is you would probably be working with compiled versions, like post-compilation versions of the other programs that you want to run, and then call those programs from something like a shell script or something. Like, shell scripting in Unix is a way of tying together a bunch of shell commands, and those commands can be running executables of different like executables that can be of any language, really. But generally speaking, if you're trying to compile something in a compiler, it needs to be the language that you're the compiler is built for. That being said, of course, there are going to be a ton of exceptions that all of the people who are like super uber programmers already know and will be talking about in chat. But yes, the fiery depths of Lucifer's most backwater servers. Yes. Yes. where MATLAB goes. Yes. Well, no, it is like 90% Fortran actually, which is kind of interesting, if you're interested in the history of things. So anyway, there's a difference between a interpreted language and a compiled language. So in a interpreted language, and this is stuff like Python and R, the program source code is translated into machine code at runtime. Sometimes that's line by line. So the advantage is that it makes it somewhat easier to debug, although that's kind of debatable. Basically, it's the difference between translating the program into machine code when you run it or up front. If you're translating it up front, that's compiling. Most languages are compiled. You've got Java, you've got C, Haskell, C++, C#, lots of stuff. Lots of stuff is compiled. Most stuff is compiled, in fact. But Python is interpreted, which means that you don't compile it up front. That's why things like the Jupyter system work, and you can sort of modify and add the functions that you're trying to develop on the fly. You don't have to stop it, recompile it, run it again. Just to reiterate, there are no tutorials this week. Tutorials are going to start next week, just in case any of you are worried about that. So, oh my god, can I blast through these slides? Yes, I can. Yes, we can. So, generally speaking, there are 3 schools of programming languages: imperative/procedural languages, declarative/functional languages, and logic languages. Examples of imperative languages are things like Python, C, C++, and C#, pardon me, and Java. This is generally the object-oriented paradigm. Then you have declarative/functional languages. These programs focus on functions and relationships between functions. They're actually based on a entirely different processing paradigm called lambda calculus. And if you have taken or are going to take one JC3, you will have seen/will see a lot of them there. Logic languages focus on automated reasoning about logical statements, and the pet example of that is Prolog. Someone has given this man a dislike on this live stream, and I'd like to argue with this person. Someone disliked me? No! My perfect record. Oh well. If you dislike me, fine. I don't like you either. Meh. Anyway. So, some of the differences that we have between programming languages include things like notation. So the operators will sometimes look a little different between programming languages. Safety. So some programming languages have stronger checks on what types things can be, for instance. That's an important one. We'll get to the idea of types a little later on. Python is pretty loose. It's got dynamic typing. There's not really much constraining you. You're just kind of expected to be a good citizen, if that makes sense. They differ in how well they support larger programs. Classes and exceptions are mechanisms that can handle larger programs. They both exist in Java and Python. C doesn't have them. C is a very basic language. Not as basic, though. Basic is another language. Instructions and standard libraries. Again, this comes, you'll hear the terms well supported. If a language has a lot of, basically the way that it works is that the number of libraries that a computer programming language has are proportional to the amount of work that people have put into that language. So the more work that people have put into the language, the more useful stuff that language is going to have, and that is proportional to the number of libraries. So some languages have many more libraries than you might think. Like something like Haskell, which is by all accounts a very academic language, has a large number of libraries for a bunch of things that you wouldn't even think that Haskell could do, like web development. Python is in that category as well. Python has a very, very large user base, a lot of people working on it, and therefore a lot of really useful libraries. Portability to other platforms, that's another thing to consider, but with big languages, it's usually not an issue. So Python, the language, was started in 1989 by Guido van Rossum from the Netherlands. It is an open language. They have a conference every year to argue about why the language is the way it is and the ways in which it could be different. Python 2 is now dead, so you should be using Python 3, but that shouldn't be a problem. Everybody should be using Python 3 at this point. The reason it's called Python is after Monty Python's Flying Circus. You may have noticed a reference to that very famous British skit comedy show in the very banner graphic for this course. It is a reference to the Spanish Inquisition, because nobody expects the Spanish Inquisition. But yeah, so it's if you look in the Python documentation, a lot of the stuff that's in there is actually Monty Python references, which is kind of cool. Anyway, Python is general purpose, primarily imperative/procedural, can be object-oriented or functional, making it multi-paradigm. It is high-level, supports many mathematical data types. It has lots of standard libraries. It is interpreted, so it is compiled to an intermediate language that interprets that is interpreted. This makes playing around with Python quick and easy. We will get into it a little bit next on Wednesday. It is also dynamically typed, which we won't talk about that right now. And it also has quote-unquote compact and intuitive notation. Personally, I also think this is debatable. But the main takeaway is that the white space is important. Things like space and tab and new line characters. So, like tabbing over and where the new lines are, this is important in Python, and this is a fundamental point, because the language itself is interpreted with those like tabs being meaningful. But we'll get into the rules of Python and how to program Python and how to do Python next class. Hoi! All right, I'm just going to check the chat to see if anybody has given me any more. Another dislike. Okay, I don't like you either. All right. So let me just check chat, see what's going on there, answer any questions that might be occurring in chat, and then we will conclude for the evening. So. A lot of nonsense. Someone did take it back. It was at 3 dislikes. Yep. Okay, so yeah, I guess. Yeah, if anybody can write a Python subbot, then you will have all of the knowledge for passing this course. Let's put it that way. It's not. I won't just give you an exam mark, but it would be if you can write a subbot in Python for this channel, then you can do anything this course will require of you. Serious question though: should I get Animal Crossing or Xenoblade 2? Very, very important question. If you want, if you like either of those series, then you should get the one that you like. Personally, like, I don't know, like Xenoblade 2 just seemed to swing real hard into the anime for me, and like, I kind of liked that, like, Xenoblade 1 wasn't quite that cheesy. Like, it was cheesy in other ways, like the story was cheesy, but like the visual design of Xenoblade 2 is like super cheese. So if you like cheese, then there you go. Animal Crossing, I don't know. I've never played them. I've never really understood the appeal. But you know, there you go. Chat seems to like Animal Crossing. Serious question about the course though. Will we learn Lambda functions? Yes, briefly. They're not going to be a huge topic, but we are going to talk about lambdas. Okay. All right, fine. Okay, but you have to admit that Xenoblade 1 was like the best thing ever. I've never played Tower of God. Okay. I don't know. I don't know. Your professor is just kind of a sucker for cheesy JRPGs. Anyway, as I said, you know, Dragon Quest is the best, better than Final Fantasy. Anyway, they're both pretty. Oh my goodness, somebody has taken this course before. I mentioned assembly code without talking about Roller Coaster Tycoon. That's true. Yeah. So what that's all about is, if anybody remembers the game that came out a million years ago called Roller Coaster Tycoon, it did something that no other video game could do at that point, and that was have nearly 1,000 little NPCs walking around a theme park at once. And the reason that they were able to do this on like Windows 3.1 is because they optimized that game in assembly code. Parts of it were even written in assembly code, and that's the only way that you can achieve that level of optimization. Anyway, that seems to be everything. I'll see you again in 2 days' time, where we'll talk about expressions. This is your professor signing off.